than a single shell command. But it made it a little faster, and one of the things that it kind of, told them is, they didn't have visibility into this before. If this was a command that took a lot longer, they would have noticed it right away, and they probably would have dug to it. But I think that when the builds get slow over months or years, it's because every little thing that's added that's wrong maybe only slows it down 2 or 3%. And by the time you've added 4 or 5 of these, all of a sudden your build is 20% slower, 25%, and there's no single thing that's causing it. So this is kind of a performance-related thing that was completely unexpected. It actually happened another time at the very next site that I was at with the early version of this product, where they were calling what they thought was a compiler, which turned out to be a wrapper to the compiler that ran 3 commands before invoking the actual compiler. And those 3 commands were uname to find out what machine they were on, and a couple of others also to determine things about the environment, which of course were the same every time. And for them, it was actually a significant hit on the performance. And they basically at the end left going, okay, we got to figure out how we can pass this to the compiler directly and call that compiler directly. One other thing I can think of that a customer discovered is they ran this, they had recently re-architected their build, and they completely started from scratch. They ran this on the new build, expecting that they would see everything neat and clean and correct, and that they would basically use the tool nightly so that it would alert them when somebody did mess up their brand new, clean, nice build. And what they saw was the compiler was called something like 687 times. And then there was a slightly different version of the same compiler called 3 times. Now, there's a mode in ToughQuery Build where you can ask for a list of all commands run sorted by the number and the number of times they will run, sorted by frequency. So if you see, one version, one path to GCC all the way on top of that list with 600 number next to it, and all the way on the bottom you see number 3 and a slightly different path to a similar version compiler, that is not something that would have been easy to find any other way. And the ramifications of that are not even clear. I mean, how do you determine just what those 2 compilers do differently? So they were very psyched. It actually turned out that somebody inadvertently included one of the scripts from the old build in the new build without realizing that that particular script was hard-coded to use something, that was not supposed to be used in the new build. So the tool, there was a question about overhead of this tool. I'm sorry if I missed a few questions. I've scrolled by. This is just the most recent one, and that I think probably a lot of people would care about. It is very lightweight in the sense that when you run your build, it adds probably less than 10% overhead to it. In fact, it just allows your build to run normally. What it does is it's observing and recording everything it sees, which is like a tiny fraction of the build. And then when your build completes, it runs a step where it saves all that information into a database. And, for like a 5-minute build, that step takes a couple of seconds. So maybe for like a really massive build, it might take a few minutes at the end. That step actually could be separated out. In that sense, it wouldn't even slow down your build. So the ToughAnalyze build command is pretty quick. The GUI can be run on any machine. It doesn't have to be on your build machine. It can be a little bit, the GUI can be a little bit memory intensive if you load a lot of snapshots into it. But again, that does not have to be loading down your build machine. We got about 5 minutes left, or even less. So let me scroll around and see if I missed anything I have time to answer very quickly. Okay. The way this is structured is there is a very lightweight, I hesitate even to call it a database, it's a SQLite file behind this where it stores the information about everything it observed during the build. which is processes run, files access, commands run, things like that. So it's not particularly large, I think, and I think we've optimized in the last couple of releases how we store information. So it's pretty quick, pretty lightweight. You can run the GUI on Linux as well. So if your build machine is a Linux machine, you could run the GUI there as well. So and then the question just popped up: if this is an open source tool. This is not an open source tool. This is part of the Coverity Integrity Center, so one of the offerings that we have to help you guys improve your software quality and integrity. So I think what happens is we have the questions. There were some of the questions that I wasn't quite sure I understood, and since you guys are on mute, I couldn't ask clarification, but what we're going to do is we'll collect those and try to answer them via email. Any sales-related questions or any, if you want to see the demo of this on your own code, again, I think emailing sales@coverity.com would be great. And then that's it. I see a couple of thank yous, so you're welcome. And thanks a lot for attending. I apologize for that. I know some of you had a little trouble with sound. So thank you.
Ladies and gentlemen, that does conclude today's presentation. We would like to thank you once again for your time, and you may now disconnect.